Good morning, students. So we have started our subject on Tuesday, that is design of machine elements, right? So we have finished some of the topic, that is what is design. Design is a process of formulating a plan for achieving a product. Mechanical engineering design involves the application of the principles of science and technology in the creation of a product and the consideration of various factors that affects its production and use, right? These are all finished by yesterday itself, but we have to see something. The basic purpose of machine is to transmit or modify the available energy from the source. So the basic purpose of machine is to transmit or modify the available energy from the source. So to produce this effect, machine requires the inclusion of certain series of links and mechanism, right? The study of geometrical arrangement of elements, the analysis of the forces involved, and subsequent design of elements so that they will not fail in operation is the subject of matter design of elements. Study of geometrical arrangement of elements. I have told yesterday itself the analysis of the forces involved and subsequent design of elements so that they will not fail in operation is the subject matter of design of machine elements. So our subject is machine design or mechanical engineering design is the process of developing new ideas for the construction of machine and expressing these ideas in the form of plans and drawings. Okay. So the mechanical engineering design is the process of developing new ideas for the construction of machine, expressing these ideas in the form of plan and drawings. So these ideas may be entirely new or an improvement upon existing design. These ideas may be entirely new or an improvement upon existing design, or it may be only partially new, right? సో మనము కొత్త డిజైన్ అయినా చేయొచ్చు, లేకపోతే ఎగ్జిస్టింగ్ ఉన్నదాన్ని అయినా చేయొచ్చు, దాన్ని డెవలప్ చేయొచ్చు, ఆర్ ఉన్నదాన్ని ఇంకొక మోడల్ లాగా తయారు చేయడం. ఇవన్నీ మనకు డిజైన్ కిందకే వస్తాయి అన్నమాట. అర్థమవుతుందా? ఓన్లీ న్యూ ప్రోడక్ట్ ని డిజైన్ చేయడం అనేది కాదు, ఎగ్జిస్టింగ్ దాన్ని కూడా మనము డెవలప్ చేయడం అనేది దాన్ని మనం డిజైన్ అని అంటాం, రైట్? ద పార్ట్స్ డిజైన్ ఏదైతే మనము ఒక డిజైన్ చేస్తున్నామో మస్ట్ బి స్ట్రాంగ్ ఎనఫ్ టు విత్స్టాండ్ ద లోడ్స్ అండ్ మస్ట్ బి అడిక్వేట్ టు మీట్ ద ఫంక్షనల్ రిక్వైర్మెంట్స్. ఫర్దర్ దే మస్ట్ బి మ్యానుఫ్యాక్చర్డ్ ఎకనామికల్లీ. So we are going to design the products, they must be withstand the loads what we are going to apply on that product, right? So that has to meet the requirements, right? And functional requirements. So after that considerations, we have also considered that the part must be manufactured economically. The part must be manufactured economically also, right? So these are the considerations we have to keep in mind while designing a product. So this topic has been covered yesterday, that is design factors. The following factors are to be considered while designing a machine element, right? So while designing a component or a product or a machine, we have to keep these factors in our mind, right? Load, mechanism, selection of materials, manufacturing processes, shape, size and quantity, right? Shape, size and quantity, effects of environment, durability and reliability, cost, life, safety. Okay, so these factors has to be considered in our mind and while going to design a product, right? We have to discuss these factors elaborately, right? So load, we know that what is load. We have covered this topic in our strength of materials. So external force acting on a component is called load. So దీనికి ఆపోజిట్ గా వర్క్ చేసే దాన్ని ఏమంటాం? స్ట్రెంగ్త్ అని అంటాం. ఓకే, ఇప్పుడు ప్రోడక్ట్ we are applying a load on that product. So in that product, there is some internal resistance force is developed, right? In that internal resistance force is developed. So that resistance force is called load, right? I mean strength. Load ke opposite what this is strength. So what we called stress. If we have considered some area, the total resistance offered by a component per unit area of cross section is called induced stress or simple stress. The total resistance offered by a component per unit area of cross section is called induced stress or simple stress. The maximum value of induced stress at which the component cannot fail is called limit stress. Maximum value of induced stress at which the component, after that this limit, the component may be failed. So up to that point we can call it as limiting stress. The maximum value of induced stress at which the component cannot fail is called limiting stress. So we know that the loads may be classified according to the type of stress produced, right? Tensile, compressive, right? And shear. The tensile may be along the axis, compressive also along the axis, shear is perpendicular to the axis, right? So these are some of the types of loads, and also according to the nature of application, steady load, varying or fluctuating, right? And shock or impact loads. Understood? So we are having different types of loads. So how we can measure the load? How can we measure the load? That means a specification of load. We have to know the magnitude of the load and the direction and the nature. So it is the most important factor to be considered while designing a product component. Okay. So the load is one of the factor while designing a component, right? So while designing a component, we have to keep in mind what is the application, what is the value of the load, and how it is acted, and what is the nature. So these three things have to be keep in mind while designing a component: magnitude, direction, and nature. Simply, we can say that the load factor is what is the value of load, and in which direction it is acted, and what is the nature of the load. So these 3 points have to be considered while designing a component, right? And next, coming to the mechanism. So without mechanism, the machine won't work, right? So if we have different types of links and some arrangements, but without any mechanism, the links may not work, the machine may not work, right? So the mechanism, we can simply say that we know some of the mechanisms, right? Reciprocating motion is converted into rotary motion. So this means this is one of the type of mechanism. Our rotary motion is converted into rotary motion. Rotary motion is converted into reciprocating motion, right? In the lathe machine also we have discussed in yesterday's session. In shaping machine, there is a Whitworth quick return mechanism. So in Whitworth quick return mechanism, the rotary motion is converted into reciprocating motion of the shaper tool. So these are all called as a mechanism. So the mechanism describes the way in which a machine works. All machines consist of at least one type of mechanism. Without mechanism, the machine cannot work, right? So simply it is a dead machine, right? Without mechanism, we don't call it as a machine, right? At least one type of mechanism has to be existed in that machine. The design process involves the selection of the most suitable mechanism. Okay, so coming to the mechanism point of view, the design process involves the selection of the most suitable mechanism. We have to select the suitable mechanism. We have different types of mechanisms existing. So, right, while designing a component, we have to select the suitable mechanism. So, that is the mechanism factor. The proportions of the parts and their kinematic arrangements should be such that they produce a desired relative motion with accuracy and minimum friction. The proportion of the parts and their kinematic arrangement should be such that they produce a desired relative motion with accuracy and a minimum friction. So, in earlier, we have discussed that the kinematic links or arrangements, right, should be such that they produce what the relative motion, what the motion we need, right, with accuracy and minimum friction. Right? Next, coming to the selection of materials, right? Till now, we have completed the two factors, load and mechanism, and coming to the selection of materials. Selection of suitable materials is the responsibility of the designer, and his success depends on the choice of the material, right? When the designer knows the characteristics of various materials, he is able to select the most suitable material to use. So we have already studied the subject of engineering materials. In that, we discussed elaborately of each material properties, characteristics, right? So with that knowledge, we have to select the suitable material while designing a component. Based on that knowledge, we have to select the most suitable material for the use, right? So selection of proper material depends upon the following factors. So the proper material we have to select. These factors have to be keep in mind, that is suitability of materials for service conditions, size and shape of the part, condition of loading to which the part is subjected, manufacturing requirements, availability of materials, and at last the cost may also included while designing a component. Suitability of materials for service conditions. That means that particular material is useful or not. First, we have to check whether designing a component, while designing a component, whether this material is meet the requirements while in service, right? If it is suitable or not, we have to check, right? After that, size and shape of the part. So based on the size and shape of the part also, we have to select the material, because some of the parts may be very costly, right? So some of the materials may be very cost. So if we are uh, doing big size product with that with that material, the manufacturing cost may be increases, right? So for that reason, here we have to keep in mind size and shape of the part also, and condition of loading to which the part is subjected. Some of the loads also influence the materials. So some products, some materials may be damaged while tensile load, and some materials may be damaged while compressive load, and some materials may be damaged shear load. So condition of loading, based on that also we have to select the particular material, and manufacturing requirements. So some hard materials we have to manufacture, the time maybe increases for soft materials. So this material properties also influence the manufacturing requirements, and availability of materials. Some materials may be available easy, and some materials may be not available in nature. So for that reason also we have to keep in mind. And cost, finally cost also influence the selection of the materials. If the high cost product is used, the cost, manufacturing cost is increases, the product cost is increases, right? So that gives the economical loss of the industry. So for that reason also we have to keep that in mind, that cost also may be increases, right? So up to now we have finished yesterday's, right, selection of materials. Now coming to the mechanical properties. Mechanical properties are associated with the behavior of materials subjected to mechanical load. Right? The most important mechanical properties are strength, modulus of elasticity, ductility, malleability, brittleness, hardness, resilience, toughness, fatigue strength, and creep. Okay, these properties we have discussed already in our strength of material subject and also in engineering materials. So we know already what are these properties. So quickly we have to finish these properties. Now strength, it is defined as the capacity to resist external loads under given conditions. Already I have told you that strength, while it is the force acting opposite to the load, right? Strength is nothing but it is the force acting opposite to the load. So it is defined as the capacity to resist external loads under given conditions. Now coming to the modulus of elasticity, that also we call it as Young's modulus, right? The ratio of stress to strain within elastic limit is called modulus of elasticity. The ratio of stress to strain within the elastic limit is called modulus of elasticity. The metals with high modulus of elasticity possesses high stiffness, that is minimum deflection under load. The metals with high modulus of elasticity possesses high stiffness, that is minimum deflection under load. Stress to strain, Young's modulus, we can denote this Young's modulus with the term capital E, stress by strain, right? Up to elastic limit means while we are applying load, the stress is directly proportional to strain. After removing the load at that elastic limit, the product is, the material is regain its original shape. That position, that limit is called elastic limit, right? Ductility. We can easily, with the ductile material, we can easily make the vice, right? So that's why we are using this material in drawing operations. It is the ability of material to deform under tensile load. Here we have to recognize this deform, not break, just deform. So its shape may be changed under tensile load. That materials are called ductility materials. This property facilitates wire drawing operations. Next, coming to the malleability. It is the ability of material to be deformed under compressive load. So ductile materials are deformed at tensile load. The malleability materials are deformed at compressive load. So due to this property, metals are hammered and rolled into thin sheets. So the ductile materials, we can make the wires from the ductile products. We can make the thin sheets from the uh, malleability materials. Malleability materials. Understood? With the ductile materials, we can make the wires. With malleability material, we can make the thin sheets because they are deformed under compressive load. Brittleness. It is the ability of material to fracture with very little deformation. That is, brittle material have low percentage of elongation. So sudden break anamata. Brittleness ante sudden break. While we are applying load, the material may be suddenly break. That nature is called brittleness. Hardness. Hardness means it is defined as the ability of material to resist abrasion, scratching, or indentation. The strength of materials మనం ఒక ఎక్స్పెరిమెంట్ చేసేదంటే హార్డ్నెస్ మీద బట్ చేయలేకపోయినాం లాక్డౌన్ వల్ల. సో హార్డ్నెస్ మెటీరియల్స్ ఏవైతే ఉంటాయో వాటి మీద మనము ఇవి చేయలేమన్నమాట. ఏంటి స్క్రాచింగ్ ఆర్ ఇండెంటేషన్ అంటే దాని మీద ఏదైనా ప్రెస్ చేసి ఉంచినా కూడా దాని మార్క్స్ అనేవి, దాని షేప్ అనేది మనకు మెటీరియల్స్ మీద పడదు. సో అది రెసిస్ట్ చేయగలుగుతుంది అన్నమాట హార్డ్నెస్ అనేది. So hardness property in the material. So we have to keep in mind it is defined as the ability of material to resist abrasion, scratching, or indentation. So this is the desirable property for the parts subjected to wear. Next, coming to the resilience, the ability of material to store energy within the elastic limit, that is without permanent deformation, is called resilience. So here the material stores some energy within the elastic limit. That property is called resilience. It is the desirable property for the parts subjected to impact loads. So impact loads ఉన్నప్పుడు మనకు resilience property అనేది ఉండాలి. Toughness, the ability of material to absorb energy before fracture is called toughness. అంటే ఏదైనా మనము టఫ్నెస్ చాలా టఫ్గా ఉందని ఎలా చెప్పగలుగుతాం? బిఫోర్ ఫ్రాక్చర్ వరకు అది ఎంత ఎనర్జీని అయితే అబ్జర్వ్ చేసుకొని తట్టుకొని ఉండగలుగుతుందో దట్ ప్రాపర్టీ ఈజ్ కాల్డ్ టఫ్నెస్. ద అబిలిటీ ఆఫ్ మెటీరియల్ టు అబ్జర్బ్ ఎనర్జీ బిఫోర్ ఫ్రాక్చర్ ఈజ్ కాల్డ్ టఫ్నెస్. A part that may be subjected to an impact load greatly in excess than the normal load should be made from the metal possessing high toughness. The property facilitates deformation rather than the fracture under heavy loads. Fatigue strength, the maximum stress at which the material will operate indefinitely without failure is known as fatigue strength or endurance limit. So the maximum stress at which material will operate indefinitely. దట్ మీన్స్ ఫ్యాటిక్ అనేది మనకి ఎప్పుడైనా కంటిన్యూస్ లోడ్ అప్లై చేసినప్పుడు జరుగుతూ ఉంటుంది ఎట్ వేరియింగ్ లోడ్స్ వల్ల. ఓకేనా? ఏదైనా ఒక వర్క్ సపోజ్ ఫ్యానే తిరుగుతుంది అనుకోండి, ఊకే తిరుగుతూనే ఉంటుంది కాబట్టి మనం వేసుకొని ఉంటాం కాబట్టి దాని మీద ఫ్యాటిక్ అనేది పడుతూ ఉంటుంది. లేకపోతే మీకు కంటిన్యూస్ క్లాసెస్ జరుగుతున్నాయి కదా ఇప్పుడు డైలీ, సో అలా కూడా మీ మీద ఫ్యాటిక్ అనేది పడుతూ ఉంటుంది. విచ్ ద మెటీరియల్ విల్ ఆపరేట్ ఇన్ వితౌట్ ఫెయిల్యూర్. అలా జరిగినా కూడా మీరు నర్వస్గా ఫీల్ కాకుండా క్లాసెస్ వింటున్నారు కాబట్టి యూ హ్యావ్ ది ఫ్యాటిక్ స్ట్రెంగ్త్. అంటే క్రీప్ అనేది ఏంటంటే కాన్స్టెంట్ లోడ్ అలాగే ఉండిపోయి మనం ఉంచినాం దాన్ని చాలా రోజులు అలాగే ఉంచినాం, అలాంటప్పుడు దాని మీద యాక్ట్ అయ్యేదాన్ని మనం క్రీప్ అంటాం. ద స్లో అండ్ ప్రోగ్రెసివ్ డిఫార్మేషన్ ఆఫ్ ఎ మెటీరియల్ విత్ టైమ్ ఎట్ కాన్స్టెంట్ స్ట్రెస్ ఇస్ కాల్డ్ క్రీప్. క్రీప్ ప్రాపర్టీ అనేది టైం మీద డిపెండ్ అయి ఉంటుంది, బట్ లోడ్లో వేరియేషన్ అనేది ఉండదు, సేమ్ లోడ్ అనేది ఉంటుంది. డిపెండింగ్ ఆన్ ద టెంపరేచర్, స్ట్రెసెస్ ఈవెన్ బిలో ద ఎలాస్టిక్ లిమిట్ కెన్ కాజ్ సమ్ పర్మనెంట్ డిఫార్మేషన్. రైట్? Creep is very important property to be considered while designing the component to withstand stress while at a relatively high temperature. The following properties inform the suitability of metal for various manufacturing processes and are referred as technological properties. These properties: machinability, weldability, castability. Right? The ease with which a given material may be worked or shaped with a cutting tool is called machinability. ఇప్పుడు మనం మెషిన్ తోటి వర్క్ చేస్తున్నాం, అది ఈజీగా మెషినింగ్ అవుతుంది, మెటీరియల్ రిమూవ్ అవుతుంది కాబట్టి దట్ మెటీరియల్ ఈస్ హ్యావింగ్ మెషినబిలిటీ. Weldability, it is the ability of material to be joined by welding. Right? This implies that the resulting joint and the area affected by the heat of welding are entirely satisfactory. Castability of metal refers to the ease with which it can be cast into different shapes. Okay, so with this I concluded today's session. Right? We have finished today properties of the materials. Right? So tomorrow we have to go into discussing about the engineering materials. Thank you.